In example 2b, our system of equations is 3x plus 5y equals 15 and 6x plus 10y equals negative 30. Okay, so we are going to try to solve this by the graphical method again. Okay, so we need to take each equation, put it in the format y equals mx plus b so that we can identify both the slope and the y-intercept for each line. Okay, and then we're going to graph each line and the solution will be at the point or points of intersection. Okay, so let's get started with the first equation. I'm going to color code it again for you. So we'll go ahead and say this is equation 1, okay, and I'll put that in blue. So we've got 3x plus 5y is equal to 15, okay. We want to solve this guy for y, so we want to get the 5y by itself. So we're going to move the 3x over, okay, so since the 3x is positive, we're going to subtract 3x, and then whatever we do to one side we have to do to the other. So I'm going to subtract 3x from the right side. Okay, so I'm going to get 5y is equal to, and remember I'm after y equals mx plus b form, so I'm going to put the x term first. So I'm going to put negative 3x, and then the 15 is positive, so I will put the plus 15. Okay, so almost there. Okay, instead of 5y, I want y, so I've got to get rid of the 5. 5 and the y, they're multiplied together. So to undo that, I'm going to divide by 5. Okay, and you have to do that. You have to divide the right side by 5 as well. But remember, from what I told you earlier, okay, when you divide this side by 5, everything has to get divided by 5. Okay, if you don't do that, you're going to end up with either the wrong slope or the wrong y-intercept. Okay, so you're going to get y equals negative 3/5 times x plus 15 divided by 5 is 3. Okay, so now that it's in y equals mx plus b form, we can identify the slope and the y-intercept. Okay, so the slope will be the number in front of x, so that will be negative 3/5. And then the y-intercept, which is the b value, will be 3. Okay, all right, and so now we're ready to graph this line. Okay, so remember, you only need 2 points to determine a line. We are going to start with our first point being the y-intercept. So I'm going to go to the graph and look at the y-axis and find 3. So our line will go through 0, 3. And now we're going to apply the slope to get other points on the line. Okay, so this slope is negative, so that's a little bit different than what we saw in example A. So remember, slope is rise over run. When you have a negative slope, you need to put the negative sign with one of the numbers, either the top or the bottom. You don't want to put it with both, because if you had negative divided by negative, that would be positive, and we don't have a positive slope, we have a negative slope. So it doesn't matter which one you put it with. I'm just going to keep the negative with the 3. Okay, so our rise is going to be negative 3. And our run is going to be positive 5. Okay, so again, this tells us how to move from the y-intercept. Okay, remember what we wrote up here, okay, when we were talking about rise over run. If your rise is negative, you're going to go down, and if your run is positive, you're going to go to the right. Okay, so when we're doing this one, this tells us how to move. We're going to go down 3, right 5. Okay, so we can apply that here, okay, to generate extra points on our line. So from the intercept, we're going to go down 3, right 5. Okay, so that will put us at the point 50. Okay, this should suffice. This does suffice for graphing the line. But remember, you're going to come back and graph the second line, and you're going to try to find the points of intersection. So it is in your best interest to keep generating the points on the line and fill out the whole graph. That way it's very, very accurate, and you can read off the point or points of intersection very accurately. Okay, so again, I'm going to go down 3, right 5. Okay, now you can also go in this direction, okay, and fill out the points this way. You just do the opposite of what you've been doing. So instead of going down 3 and right 5, we're going to go up 3, left 5. Okay, so from here I'm going to go up 3 and then left 5. Okay, so that's going to put us right here. Oops, 1, 2, 3, 1, 2, 3, 4, 5. So that puts us at negative 5, 6. Okay, and then I'll do it one more time. So up 3, left 5. Okay, so there we go. All right, and so now we can connect the dots, and that's going to give us our line. Okay, remember, if you're plotting this and you get a stray point that doesn't fall on the line, check it. You probably misplotted something. Okay, everything should fall on the line. Okay, I'm going to go ahead and label this with the equation. This is 3x plus 5y equals 15, the first equation. Okay, all right, so now let's go back and deal with the second equation. So the second equation is 6x plus 10y is equal to negative 30. I'm going to put that one in red. Okay, so again, we need to solve this guy for y. So I'm going to write it down. 6x plus 10y is equal to negative 30. Okay, all right, we want to get y by itself. So I'm going to isolate the 10y. I'm going to move the 6x over. So I'm going to get 10y is equal to negative 6x minus 30. Okay, both of these terms are negative. Okay, and again, I'm writing the x term first to make it look like y equals mx plus b. All right, so now we want y by itself. Y is multiplied by 10. So I'm going to divide by 10. Okay, and on the right, everything gets divided by 10. Okay, so we're going to get y equals negative 6/10 times x minus 30 divided by 10 is 3. Okay, and then I'm going to go one step further. Notice that negative 6/10 actually reduces. Okay, both of those numbers are divisible by 2. So negative 6 divided by 2 is negative 3. 10 divided by 2 is 5. And so my slope reduces to be negative 3/5. So I actually end up with something very similar to the other line. Okay, it's a little bit different. They have the same slope. Okay, so the slope here is negative 3/5, the number in front of x, but the y-intercept is negative 3. So it's got a different y-intercept. Okay, so let's go ahead and plot this line. Okay, again, we're going to start with the y-intercept. The y-intercept this time is at negative 3. Okay, so it's going to be a different line, even though they have the same slope. Okay, again, from this point, I'm going to go down 3, right 5. Okay, and again, down 3, right 5. Oops, 1, 2, 3, 1, 2, 3, 4, 5. Sometimes I can't count. All right, and then again, reverse it. So up 3, right 5. Okay, up 3, right 5. Okay, and then draw your line. And look at what happens here. Okay, so let me go ahead and label this guy. All right, so this line has the equation, let's see. This one is, I'll label it over here. This is 6x plus 10y is equal to negative 30, okay? There is no intersection, okay? The lines are parallel. They never cross, okay? If you think back to algebra, when you took algebra once upon a time, okay, how do you identify parallel lines? Parallel lines have exactly the same slope, okay? These lines have the same slope. Both have slope negative 3/5. But they're different lines because they do not have the same y-intercept, okay? So I'm going to write here that these are parallel lines because they have the same slope. Okay, and since they're parallel, there is no intersection point. Okay, and so remember, if you're solving a system by graphing, okay, you graph them out and you look for the intersection points, but there's no intersection. So What does that mean? Well, if you're going back to the system has no solution. Okay? Meaning there is no variable assignment. There's no assignment of x and y that if you plug those values into both equations, you get true statements in both cases. Okay? There is no such thing. Okay? So this is our first instance of a system having no solution.